We're going to start. We're going to start with the traditional math contest coin flip. Mr. Foster, over here. Mr. Miesse, you are the visitor. This is heads. That is heads. You call it before I flip it.
Go tails.
Tails. Call. And it is heads. Mr. Foster, would you like to receive or kick off? I'll defer. Defer? So that means you...
I guess I'll take the ball.
Mr. Miesse is receiving. All right, let's get this thing going. Mr. Miesse, you are up first.
All right, well, thanks for coming. It's a great honor to take part in this debate. For you know that there are many issues of great importance in the history of mankind. Moments when paths are chosen, policies set, crossroads for which only one road leads to success and the other to ruin. There are times when decisions must be made, decisions that can alter the future of a country, a nation, even mankind as we know it. There are indeed times that try men's souls. But thankfully, ladies and gentlemen, tonight is not one of those times. For the decision of whether pi or e is better is not one that will determine the success or the ruin of our nation. So what are we doing? Rather, we're being like Isaac Newton. He called himself a boy playing on the seashore. I'm diverting myself now and then with finding a smoother pebble or a prettier shell than ordinary. Pi and e are prettier shells than ordinary, especially pi. No. Especially e. We want to share these shells with you, be able to think and learn and laugh at the beauty of these two numbers. Ultimately, this debate's about the fun of learning, and so who better to share this debate with than my colleague and friend, Dave Foster. Dave's a man who epitomizes what... He epitomizes what the teaching profession should be about. So with passion for students and for knowledge and for learning and fun. So it's with great pleasure that we pursue this truth, looking for the truth of these two numbers, pi and e. So let's get started. There are a lot of things about pi and e that are similar. Pi and e, and mathematicians would put them both in some categories of numbers. One of those is irrational. All you high school students, you know what that is, right? All right? It means you can look at it. You cannot put pi and e into a form of fraction with an integer on the top and the bottom. Pi and e is just a little bit more technical type of number than they are, and they're both, irrational. There's pi and e as decimals. They just go on forever. You know that, right? A little more technical term, transcendental numbers. You might not know what that is. It means that you cannot write a polynomial equation with integers and solve it and end up with pi or e for an answer. And there's an even more technical term. Pi and e are both really cool numbers. All right? That's a little bit higher math, but okay. But there are a lot of differences between pi and e as well. Pi is ancient. We've known about it for thousands of years. E is a relatively young whippersnapper, only a few hundred years old, as we know of. Okay? In addition, Mr. Foster and I are big football fans. We both went to the University of Michigan, love football. And we try to look at the difference between ancient and young. You can think of it almost like this. There is ancient, like pi. And here's a little bit more young, like E, right? And Connor Hubble, I don't know, which helmet would you rather wear? Pi or E? right? In addition, pi is pretty simple, and E is complex, right? I mean, what is pi? It's just the ratio of the circumference divided by the diameter. People know that even in elementary school. That's a simple concept. E, on the other hand, boy, what is that? That looks like calculus. It's got limits, and it's an indeterminate form. It's all kind of crazy stuff. It's complex. Of course, you might wonder which is better, simple, complex. I was talking to a young man, Marty Siemens, today about Valentine's Day. He said he was thinking about maybe inviting a young lady to join him for Valentine's dinner. So I was thinking, what kind of dinner should Marty prepare? Okay, it's a great romantic thing to prepare a dinner. Should he do a simple one like pie? What would be a simple dinner like pie? Maybe that. Marty, if you want to be like pie, you could prepare a young lady a nice dinner for Valentine's Day. It'd probably be one that you never forget. Okay? Or you could be a little bit more like E, something like that. It's definitely more complicated. And so you have to say, is complicated better or is simple better? And finally, pi, another big difference, pi is pretty famous. Everybody knows about pi. And I'll bet some of you maybe came in and said, I don't even know what E is, or I've forgotten, or whatever. People all around the world know about pi. It is famous, so it's famous. Good. Of course, I was thinking, well, who's famous? Well, she's famous, right? Miley Cyrus. I know this is an old picture, but I couldn't find any recent ones that were suitable for the that's famous. That's like pie. Everybody knows her. There are a lot of other people in the world that are not quite so famous. Okay? Like maybe this guy, right? Now, not everybody in the world knows him, but in a way that's kind of like E. And you have to ask yourself, with which one of these people would you trust the future of our country? or with which one of them would you maybe trust to teach your children, right? So, famous is not necessarily better. But because E is not as famous, you need to spend a little bit of time just making sure you know what E is. E is an irrational transcendental number. It's 2.71828, keeps going like that. It's the base of the natural logarithm. A lot of you guys know about logarithms. It's also Euler's number. Now, who is Euler? Euler maybe is the greatest mathematician to ever live. There he is, he's got a nice outfit. And he is Euler's number, the greatest mathematician ever. I was thinking, does pi have any mathematician that has ever claimed it as their number? I looked and couldn't find any, maybe because pi is so ancient. So maybe it'd be more like this guy, Fred's number. That was the best I could do. So we've got the greatest mathematician ever and then this guy. So what's so special about E? What's so special about E is when you combine it with the letter x. If you take the function y equals e to the x, it looks like an exponential curve. There's something special about this curve that no other curve has. See, in calculus, we talk a lot about something called the derivative. It's just a fancy way of looking at the rate of change or the slope of the curve. And there's something really special about e to the x that no other function has. See, when the value of the curve is 1, the slope of the tangent to the curve is 1. You think, well, some functions have that. What's so special about that? But when the value of the function is 2, if you take the tangent line of the curve, if you count that, it's going up 2 and over 1. The slope of the tangent line is 2. When the value of the curve is 4, the slope of the tangent line is 4. And that's what makes E so special. There is no other function like that where the slope is equal to the value of the function at every point on the curve. So why does that matter? Well, because that allows E to show up in all kinds of applications where the rate of change depends on how much stuff you have. There's a great quote. It says, "Who has not been amazed to learn that the function y equals e to the x, like a phoenix rising from its own ashes, is its own derivative?" So because of that, E shows up in places like population growth, right? Where do you think they had more babies born today, India or Iceland? Definitely India. Why? Because there are more people in India, right? So the population's bigger, that makes the rate of change bigger, right? The population's dependent on the rate of change. You need a function where those two things are so closely related. E to the x is your function. That shows up in bacteria growth. The more bacteria you have, the faster they grow. It shows up in radioactive decay, where the more stuff you have, the quicker it decays. It shows up in money, compounded continuously, right? It's the best way to gain money and have a lot of money. Okay, the more you have, the quicker it will grow. It shows up in Newton's law of cooling, spread of a disease, all kinds of applications where the rate of change is related to how much stuff you have, and that's what makes E so special. But E also shows up in some other places, like a catenary curve. Maybe you didn't know this, but if you hang chain between 2 points, it forms a curve. It kind of looks like a parabola, right? But it's not. The equation is actually something called a catenary, which involves E. And that becomes pretty important for guys like me, because I was a math major, and like most math majors, it was a little socially awkward, okay? And so it wasn't that easy to try to meet young ladies and things like that. But with knowledge like this, it could be done. Because you might go to a party in college and see a young lady wearing a necklace like that, and come up to her and say, "Hey, nice double catenary," which really has a couple great effects. I mean, first of all, she might look back at you and say, "Wow, I too am a lover of the number E." And you're set. And that's how I met my wife. But there's also the possibility that she might just look at you with a confused, dazed look. And at that point, you have a couple options. You could realize that maybe she's not the one for you. Or maybe you've got something to talk about. You could tell her all about E. And that would be quite the conversation starter. So it's good to know about catenaries. If you have catenaries that are inverted, you end up with things like that. All right? St. Louis, the Gateway Arch. It's a great symbol of our country's expansion westward. And guess what? The equation of that, an inverted catenary involving E. The engineers who put that together had to use equations involving E. I feel like I am neglecting pi, though. Pi shows up in architecture as well. Things like you get on and you go around and get to the end and you come back off. So I don't want to neglect that. E also shows up in logarithmic spirals as small as the Nautilus shell and as great as galaxies far, far away. But you still might be wondering, you might say, well, it sounds like E's a great number, but does it really matter for me on a more personal level? Well, most of you guys here are math students, right? And so I was thinking about maybe a typical math student. We'll call him, I don't know, Frodo Baggins. Typical math student. There he is, hard at work on his typical math problem. Solve the following differential equation for y. And Frodo has great algebra skills, like a lot of you, and he knows that he needs to multiply both sides by the x and divide both sides by the y. And then comes the calculus. He says, all right, we need to integrate both sides. But at this point, there's a frightening thing for poor Frodo. Because on the left side of the equation, he realizes that the only way to get through this solution is to enter the land of logarithms. So Frodo goes, with great fear and trepidation, into the land of logarithms. And in the land of logarithms, he ends up with a natural log of y. But at this point, he's stuck. Because he's trying to get y all by itself. And he's wondering, how do I ever get rid of that natural log there? And he looks toward his teacher. Now, his teacher is not a teacher like Mr. Foster. Or like me. This is a teacher, and all he sees is the evil eye looking back at him. Okay, that's the bad math teacher. Maybe you'll see that person in college. I hope not. But and then Frodo looks to his trusty friend, his friend Sam Ganji. He says, Sam Ganji, can you help me get out of this land of logarithms? And you know, Sam has been with him since he was a young boy. Sam is a simple, nice friend. But Sam is of no help whatsoever in this situation. And all he can think of is, they're at the end of all things. They are stuck in the land of logarithms forever when, like a phoenix rising from its own ashes, here comes, now I know that looks like an eagle, but it's really a phoenix coming to save the day for Frodo and even his friend Sampai. E ends up in the equation, gets y by itself, and we end up with a happy math student. So that's why E is such a special number. It's there for you in your time of need. Thank you.
Looks like a nut.
While Mr. Foster is getting ready, remember that if you want to ask the questions right here, this is the phone number to text you. Make sure you include that in the front of your text.
Can't see it.
That's okay. Just pretend. Yeah. There you go. Text it to this number. There at the beginning, there's some great questions. I wish it could be a little more sarcastic.
I just put that up there to show you it's not a real simple formula. It does take an infinite number of sums to do that. But that's okay. I just want to show me. I decided when Mr. Miesse challenged me to this, or invited me to this, that I wanted to do one thing that was unusual in political debates. This is not a political debate, but I don't think I'm going to poke fun at E once, because it's a wonderful number, just like Mr. Miesse is a wonderful teacher. In fact, I wanted to thank the two people up there. Mr. Cole, my son had him. He learned a lot from him. He made it fun. Mr. Cole's giving up his time to do this. And when I first started teaching here, I taught Calculus BC. And when Mr. Miesse came to the school, I wanted to give him a chance to pursue his passion. So I gave up teaching Calculus BC because I knew nobody could teach it better. And I've had a lot of people come back from Michigan and say when they took Cal 3 as freshmen, they were better prepared for Calculus 3 than the kids who had Calculus 2 at the University of Michigan. He's a wonderful teacher, he's a national treasure, and I just want to tell you, congratulations. Now I want to tell you a story about the coin that was used for this, to start this. My nephew flies jet fighters for the Navy. And the first time he went and had to land on the aircraft carrier, he took this up with him. And the first time you go up, they make you go up alone because they don't, if you make a mistake, they don't want anybody else in there. I knew him ever since he was a kid, and he took this with him. And when he came back, he gave it to me. And I wanted to use this for the coin flip. And I just want you to know the area and the volume of this is pi r squared h, so pi is in this. It's pretty special. I want to share another story. In 1957, I was like 5 years old, and I always liked to look up at the skies. And I remember at 5 years old, Russia had sent Sputnik in October of that year. And we'd go up and look at the stars, and my dad would say, look at that thing going around. And then by the time I got into 3rd grade, America said we really had to catch up to the Russians. So they had a big push in math and science. And I remember as 3rd graders how we learned. We learned because we had desire and curiosity, and we thought it was a matter of national security. So when we talked about pi, we didn't take our teacher's word for it. They made us go out in the dirt and make lots of circles and then measure them by putting a string around the circle, and measure the diameter, and then they want us to compare the circumference to the diameter to see how well we could measure. And then that wasn't very good, so we tried to come up with better ways. So we would wrap it around the soup can really tight, and pull it tight, and that was a better measure. And then the diameter is like the widest way you can go around the circle. So after a while, we said, oh, the circumference is about 3 times as big as the diameter. And then the teacher would say, well, is it exactly? Be honest. You know, we were 3rd graders. We thought it should have been exactly, but most of us said, no, it's a little off. It's a little bit more. It was always just a little bit more than 3 times. And she thought that was very good. And then we said, well, how much more? And she said the smartest people in the world would have to take calculus to teach that. But if you work hard enough and take calculus, you're going to get a glimpse of how much more. I want you to know that in this county, if you take calculus BC, that's the first time you start getting a glimpse of how pi is calculated and how E is calculated, and you get one of the best educations in this nation. I started teaching in a private high school, and when I came to Cranbrook, Kingswood, and when I came to St. Joe, I said, well, at least in math, if anybody takes math at this school, I want them to get as good an education as anybody in any private high school. And to me, that's part of my passion that you mentioned. Now, when I got pi, I decided to look at this book. I said, whichever number I got to first was probably the best number. And this book, the only reason I really like it a lot is a student gave it to me. So Haley Bells gave me this book, she's in your class. And on page 17, it says, one particular number appears to guide the lengths of meandering rivers. Cambridge University has calculated the ratio between the actual length of rivers from source to mouth and their direct length as the crow flies. In fact, that ratio turned out to be pi. Wow. However, there is a natural process that and they go on and explain why. So part of that reason is it's really a lot more than circles, as I will talk about. This is the way I teach when I get through my stuff. Do we show this, please? Now you're supposed to learn something, so at least when everybody leaves here, if somebody asks you, what is pi, what is E, I'm hoping you're going to be able to tell them what pi is. No matter which circle you do this to, if you measure the circumference and then compare it to the diameter, the circumference is always pi times bigger, which is slightly more than 3. It doesn't matter the circle. And in 3rd grade, I thought that was really amazing. Now that's not a big deal, this thing, if you can imagine. You know, as 3rd graders, we'd put a string around there, and then we would take a stake in the dirt and make the circle. And then where the center of the stake was, we would measure the diameter, and then we'd cut the pieces of string and do it. And it always turned out to be pi, and I'd like to show the history slide. I didn't make, so I found a couple slides, or a couple movies I'd like to show you. So go ahead and show the first one.
I'm getting there.
Since the dawn of mankind, there has been one number that everyone knows, even if they are not in competition. The number is pi. The public is aware of its importance in circles, literally and figuratively. In fact, there is even a motion picture within pi. But where did pi come from? And who first discovered it? Has it always been 3.14? We'll first start by investigating a circle. Pi is the circumference of a circle divided by its diameter. In this example, we will let the diameter of the circle be equal to 1. Then, if we measure the circle along the graph, we will receive pi. This concept has been known for thousands of years. From writings written more than 3,500 years ago, the Bible reveals the existence of pi in the scriptures. In the King James Version, 1 Kings 7:23 states, "And he made a molten sea, 10 cubits from the one rim to the other. It was round all about, and his height was 5 cubits, and a line of 30 cubits did compass it round about. In the New Living Translation, 2 Chronicles 4:2 states, "Then he cast a great round basin, 15 feet across from rim to rim, called the sea. It was 7.5 feet deep and about 45 feet in circumference." There is some indication.
Now, the reason I wanted to show that is pi has been around as far as people have known. I mean, you know, the cosmos would laugh at us because pi's been there forever, he's been there forever. But as far as human species, we've thought about pi many, many thousands of years before we thought about E, about 4,000 years. Now, my point is, people like Isaac Newton, Galileo, Archimedes, Einstein, Pythagoras, the Greeks, they thought about pi, and to prove what it was, they had to really think. And my premise, and I really believe this, if it wasn't for us thinking about pi and then discovering things about the world, we might have been extinct before we ever got around to E. Because we should have been extinct if you think about things. The saber-toothed tiger is faster than us, it has sharper teeth, you know, it should have devoured us. But because we could think and develop things like pi, I think that's why we were alive to be around for E. For example, I'll just do that later. A couple other little facts. In 2002, a powerful computer called the Hitachi SR8000 computed pi up to 1.24 trillion digits. And I read where pi is now the EKG of computers to see if the computers are working well. I'm not making fun of me, but they always seem to use pi for stuff like that. As far as the cosmos, the disk of the sun, the spiral of the DNA double helix, in physics, sound waves, light waves, it enters into equations that define precisely how we can know the state of the universe. I think that's about all I wanted to say for the beginning, except I'd like to show this slide. It's not a big deal, but I just want you to know there's going to be an epic moment, March 14th, 2015, at 9:26 and 53 seconds, which is 3.141592653, and that scribbling on the side says, if anybody texts me within, no, I'll read it, just for fact. If anybody texts me within about 5 seconds of that moment, and if you happen to somehow tonight express that you love pi, I will give you tickets to a Rose Bowl game and a Final Four during March Madness.
Wow.
And that's not a bribe. That's not a bribe, but you will have to know my text. I'm going to sing it. Now, you know, this is little St. Joe High School. We're supposed to decide which number's better. MIT is a pretty reputable source, and they offer acceptances to their school at 3:14 on March 14th. So MIT didn't do that on February 7th. I'm not making fun, I'm just saying MIT decided on time. And I don't think this is a coincidence. Albert Einstein was born March 14th, 1979, which is Pi Day. And that was not a coincidence, and that's my opening statement. I guess this is a video because there's a couple things I love, and I'll get to this in my conclusion. I love music, I love sports, and I think Pi is dear to those things. Here's a American Pie, great song. Here's a little song about American Pie.
A long, long time ago, long before the Super Bowl and things like lemonade, the Hellenic Republic was full of smarts, and a question resting on the Grecian hearts was, what is the circumference of a circle? But they were set on rational numbers and ranks among their biggest blunders. They worked on it for years and confirmed one of their biggest fears. I can't be certain if they cried when irrationality was realized, but something deep within them died. the day they discovered pi. Thinking pi, mathematical pi. 3, 5, 8, 9, 7.
Just give us a couple seconds where you're going to see Mr. Foster, did you have?
I might conclude my rebuttal.
Mr. Miesse, do you have a rebuttal you wanted to?
Not at this time.
No rebuttal.
At this time. He was careful to say.
Yeah, come on over and take a look at this. We're going to see if anybody actually had a good question.
Are either pi or the natural number used for the equation that defines chaos? That's a great question. All right, next. Can you explain why e to the I pi equals -1? Yeah, that would take a while, but it does. Let me just put this up.
I might have known that, but
This is known as Euler's equation, probably I think the greatest equation ever. And it does have both numbers in it. E raised to the I pi, I'm going to write it this way, +1 equals 0. A lot of people say the 5 most important constants in the world, E, I, pi, 1, and 0. And Euler, that great mathematician, figured that out. It takes some calculus and infinite series to work through that. Involves cosines and sines and things like that. And no, I can't explain that in the time we have here. You'd be bored. Okay.
I think, wow, some really, really great questions. Great questions. I just want to say Mr. Miesse does indeed look fly. To whoever sent that, that's terrific.
I don't know what that means.
That's not even English. So, Mr. Foster, you want to do your conclusion?
Sure. Yeah.
Which one do you need while you set it up? This.
Yeah. Chunk spot.
Gotcha.
All right, here's my conclusion. I'm going to start with a little film.
Hold on.
that's a good idea.
Also a scanning computer access a certain mathematical problems will simply cannot be solved. We could focus the attention of the computer on Computer, this is a Class A compulsory directive. Compute the last digit, the value of pi. As you know, the value of pi is a transcendental figure without resolution. The computer banks will work on this problem to the exclusion of all else until we order it to stop.
The point of that was that I think the computer was taking things over, so they had to ask it a problem that it couldn't solve by computing the last digit of pi. Now, he could have asked it to solve for the last digit of e, but they always seem to talk about pi. Now, you said things that are more famous, but you know, Tiger Woods is a better golfer than Jim Smith, so he's more famous for a reason. And so I guess that the fact that Spark and MIT both acknowledge pi is something I wanted to talk about. So I just did. All right. By the way, February 7th is come and gone. February 7th might have been E-Day. Nobody's ever told me Happy E-Day. Although for 34 straight years of teaching, everybody talks to me about Happy Pi Day. I just wanted to mention that. And by the way, you know, it's more than circles. There's three-dimensional circles called spheres. And I believe this to the depths of my depths, and the lowers of my lowers, and the middle of my middles, that there's spheres in atoms, there's spheres in suns, from the smallest thing in the universe to the biggest thing in the universe. In fact, the universe itself might be an expanding sphere whose volume is 4/3 pi r cubed. Not only that, there's the wheel, the first big discovery that saved our species from extinction. I just wanted to mention that. And by the way, something else is true. Pi is fun. I want to talk about that for a little bit. I'm not sure what's in here, but I'll see. I happen to like sports, and this is a sphere. That is oh, and by the way, if anybody has a piece of paper, get it up. I want to do an experiment. If you have a piece of paper, get it up. I'm going to give you a 30-second experiment, and then another 30-second experiment. And if you report the results to me later, I'm going to give you a free round of golf on Pi Day 2017. If you text me, 314. All right, for 30 seconds, write this down. 30 seconds. Name as many sports that you can think of that involve a sphere. Go ahead. The better. I just want to see how many you get. Name as many sports as you can think of that involve a sphere. If you don't have a piece of paper, think about it. Or you can text me.
Hey, this isn't a multiple choice. Do it on your own.
Or actually, write these down. Just send me an email. Tell me how many you got. Or if you don't have one, you can do it on honesty. Do it in 30 seconds. All right? End of the experiment. Okay, next experiment. Spend 30 seconds and tell me how many sports you can think of that involve E. I'm not making fun of it, it's just a fact. Okay, that's my point. My favorite birthday cake is an angel food cake. There's a cylinder, there's a round thing. It's fun. I use these all the time to talk about calculus. I think this has some music on it that looks pretty pie-like to me. And if we beat Lakeshore, I don't think we could have beat Lakeshore without the spheres. Oh, yeah, and on Pi Day, people bring me pies. I think on E-Day, they might bring you a natural log. Go ahead. This reminds me, here's a pie for Mr. Cole.
You know, we're not going to do 2 pies there. I did make one today for me.
Yeah. He could have been thrown to you. That has tire.
What was it? Oh.
These batteries are cylinders. I don't know why. This might break, I know, Becky. This came from homeless class, but it's a cylinder. I found it on my way out. There's no sock.
Such is my life. Oh my God.
Listen, this is some of my best time of my life, playing catch with friends, using spheres like baseball. Oh, I gotta talk about baseball. You know, or tennis. And I didn't eat lunch today because I was worried about this debate. And this was in a cylinder, okay? I'm a little bit... Anyway, baseball, spheres. Actually, it tasted good. I needed it, actually. I'm ready now, Mr. Cole. I'll calm down. World peace. of the round table. They got it gathered around the round table so nobody would be at the head of the table. That was beautiful. I want to show this one. Time is the most valuable thing we have. I love time, I love this moment, and there it is, time going around the circle. Oh, and sports, and cars. If you love sports, anytime you play sports, you know, in a way, if you don't vote for pie, I don't want you playing this stuff. I want to end with two poems, and I'm going to do it, two poems, and then a video. Americana, baseball. One of my favorite poems. I'm just going to read part. Casey at the bat. And from 5,000 throats and more, there rose a lusty yell. It rumbled through the valley, it rattled through the dell, it knocked upon the mountain and recoiled upon the flat. For Casey, mighty Casey, was advancing to the bat. And now the leather-covered sphere, volume 4/3 pi r cubed, came hurtling through the air. I love that poem. Okay. Consider, if you will, the amazing number pi as a never ending, as myriad uses keep ascending. Based upon the circle, many people have tried to calculate its vestige, but they have only tried. To our human race, it's been a great addition, and pi deserves only our highest recognition. If you cannot understand why I hold this number so very high, that is fine with me. I'll still forever love the number pi. It is transcendental and irrational. It cannot be made a fraction, and the challenge of its nature has often been called to action. Yes, pi plays key roles throughout the heavens and the earth. From the atom to our sun, it always proves its worth. From the tires that you ride on to the spheres and sports, that are so fun, only pi is there throughout. It is number one. Now we play my next video. It's a sphere. You're going to have to go home on wheels, or you're going to have to...
Thanks, that's tough to follow. Yeah, pi and E they're both great numbers, aren't they? And, you know, that sphere, that hurling planet that we're on, always going around and around, when you think about where we're headed, the world seems to be changing faster and faster and faster. Faster than ever, right? I mean, things are not the same as they were a year ago. Think things are going to look like in 10 years. We don't know, do we? I mean, we know that pi will be a circle, but how's pi going to handle change in life? You know, there is one function that handles change like no other, and that function is e to the x, because there are two things about change that are issues for us. We have to learn how to adapt to it, to deal with change, but at the same time, we don't want to lose who we are as a people. We don't want to lose our heritage. And guess what? There's a number that, even though it changes, can handle change, it still remains the same. Why is that? Because like a phoenix rising out of its own ashes, the derivative of e to the x is e to the x. What better number to handle the change that we're going to encounter than a number that can stay true to itself? It handles change, and yet does not change itself. So I would encourage you, when you think about that, circles are nice. Circles can't handle the change the way e to the x can. Vote for E.
Folks, looking at the rules of the competition, Mr. Foster, I'm going to have to actually ask you to disregard some of his comments. Everything after Mr. Cole and Mr. Miesse, just flat out disregard that because of the drives with the golf. What we've got, we're going to do some quick voting here. Some great questions.
We have to use our phone.
So here's the poll. It's going to be, if you thought high, it's 300477. Text it to that number. Right
what
now.
number?
Let me get those numbers again. Because 300477, 300478. You got those?
No,
All right.
of course not.
Because I thought it would stay up there. It is. Mr. Foster, switch that over. No, I'm kidding.
37 something. It's 37 something. 607. 607.
There you go.
Well, the pi number should have been 3.159. And E should have been whatever, yeah, 27. Yeah.
Wow. Ton of results coming in. Literally, figuratively, a ton of results coming in. I think we actually have a winner. I'll put it up here on the big board. You all got that? Vote. Feel free.
Poll has received, yeah. I said it was.
Maximum number of this. You know what? Some political legitimacy has to be given up in the. Let me take a look. All right, I'm going to go ahead and display the results so far. And these are official.
3.14 to 2.7, yeah. 34 to 17. Yeah.
So just looking at it, I believe has won. Mr. Foster got 3.141592654 votes. Mr. Miesse, 2. Don't call me. They both wanted it to be anonymous, so I will have the results and keep them to myself. Nobody else will be able to find out.
All right.